my geometry people. Welcome back. Today we are going to be talking about volume of prisms and cylinders. So turn to page 749, 11.2. 11.2, page 749, volumes of prisms. Now I was at home when I taught you 11.1, so I didn't have all my fun little 3D shapes with me. I had to use like a can of olives. But today I have my little 3D shapes. It's exciting. I'll be able to show you a little bit more volume stuff when I have the actual correct thing. So that's awesome. So volume is how much stuff will fit inside. In other words, if I have this big shape right here and I poured sand in it and saw how much sand would fit inside this, that would be volume. How much stuff can fit inside, okay? And to do the volume, for some shapes it's really easy, like a rectangular prism, because the base is the shape of a rectangle. To do it, we just find the area of the base and multiply it by the height. So if the area of the base was like 4 times 2, I would do 4 times 2, which is 8, and then if the height was 5, let's say, I would do 4 times 2 to figure out the area of the base, and then I would multiply it by the height. Think of it like if we have a cylinder. I'll show you using a cylinder so you can kind of see how. Pretend this is like a stack of quarters. And let's say there's 20 of them in here, stacked up in here, okay? If I had the area of 1/4, which is the shape of the base, and then I multiplied it by how many there are, which is 20, which is also my height, then I would know the volume. Okay, so basically to find the volume, you're finding the area of the base and then just multiplying it by height, which is like how many of those are stacked up in there, okay? So let's look at volume of a prism on page 749. In our equations, when we have a capital B, that means the area of the base, okay? Lowercase b means the length of something. A capital B means the area of the base. So in our triangular prism that we have there, the volume of a triangular prism, you find the area of the triangle, that's the base, and you multiply it by the height. Base times height. Area of the base times height. Capital B times H. Let me write it down for you visual people. Oh, can't get the cap. Okay. Volume equals area of the base times the height. Remember that capital B means the area of the base, the whole area, okay? So your volume of a right rectangular prism, the area of the base, which is length times width times height. Okay, so it's the area, the same equation, area of the base times height. They wrote it as length times width times height, but that's the same thing. Whatever way makes sense to you is totally fine with me. Okay, lastly on that little section is a cube. Remember, everything about the cube is exactly the same. So to find the volume of a cube, we do side times side, or side squared, because they're the same, 4 times 4 times 4, right? So you know how you hear the term, if it's something, like if you have it labeled feet cubed for volume? That's because if you have a cube, it's one side, 2, 3, and they're all the same. So it's 4 cubed because they're all the same. So that's where they get that little term from, okay? So volume is labeled something cubed. All right, so let's look at example number 1. Find the volume of that prism. Okay, you guys, some of you are not reading directions very well. If it says round to the nearest 100th, this says the nearest 10th, that doesn't mean I want a fraction as an answer. It means they want a decimal point rounded to the nearest 10th as the answer. Please read the directions. Okay. All right, so the volume of a prism. So it's 10 by 12 and it's 8 high. So mine is not quite right, but 10 by 12 by 8 high. So you just go 10 times 12 times 8. That's all you have to do for those ones. They're great. Okay, so that would be 960, and you would label it centimeters cubed. Now a cube, remember, looks like this for B, example 1B. A cube with a side length of 10. Well, remember on a cube, all the sides are the same. So 10 times 10 times 10, or 10 cubed would be your answer, which is 1,000, right? And we label it centimeters cubed. Okay, let's turn to example C. Example 1C. This one is a little bit more tricky because it has to deal with those polygons as the bases, and those polygons are super tricky because the way you find the area of a polygon sometimes is really tricky. So we'll review that because it can be super confusing. So remember, it's apothem times perimeter divided by 2. That's how we find the area of that base. And then we're going to multiply it by the height, which in this case, because it's laying down, is this length here, right? So we're going to find the area of our base right here. And then we'll multiply that by the height, which for us is 7, okay? So here we go with our shape. They already did some of the work for us by telling us that this is 36 degrees. Thank you for that. And that this is 5. Awesome. That's super helpful. Hopefully you remember, if I have a degree here and a side, I can use tangent to figure out this little section right here, right? So the tangent of my 36 degree angle is opposite, I don't know, over adjacent, which is 5. We could go ahead and multiply those two numbers, and they're going to tell us that I'm looking to see, did they tell us it was, no, I'm looking to see, so I don't have to do it. I'm looking, how come I can't find where it says what it is? Oh, because they never actually do it out. Okay. All right. So they do the apothem, which is actually this equation right here, times the perimeter, okay, which, oh, they figured that out for me. Oh, the whole thing is 5. You guys, I'm totally messed up. The whole thing is 5. We already know that. Fantastic. So if the whole thing was 5, you know this is 2.5. It's this way. My bad, you guys. Okay. So perimeter would be 5, 10, 15, 20, 25. So you would figure this out to get the apothem. I was totally not looking very well. I apologize completely. Just pretend we're starting again. Okay, so it's our 36 degrees. I know that this half is 2.5. I use tangent, opposite over adjacent to figure out my apothem. Whatever that answer is, which they're just leaving in an equation form, which is not helpful. We're going to do apothem times perimeter, which we figured out was 25, divided by 2. And we'll get that the whole thing is 301.1 total. Okay? Because they'll find this and then they'll multiply it by the height. I'm sorry, that was really confusing because I was reading that wrong. I apologize. I'm horrible. I'm horrible at my job. So let's review. Use tangent to find the missing apothem. Apothem times perimeter divided by 2 gives you the area of the base. We take that area and we multiply it by the height, which for us was 7. Whew, sorry, that's a total teacher fail right there. Okay, example number 2. Okay, so the aquarium at the right is a rectangular prism, and estimate the volume in water in the aquarium in gallons. Okay, so we can easily get the volume, right? 60 times 8 times 120. So 60 times 8 times 120 will give us our volume, which they did for us, and it's 57,600. I just did 60 times 8 times 120. I'll write it up here in case you need to see it. Length times width times height. Okay, so that's my volume. All right, then it says the density of the water is 8.33 pounds per gallon, and then it says to estimate the weight of the water in pounds, and it tells us that 1 gallon is that many cubic feet. So we have found the volume. We now need to turn it into gallons, okay? Because we need to deal with gallons because our pounds per gallon, okay? So we have our volume. We need to turn it into gallons. They gave us that helpful little hint that 1 gallon equals 0.134 feet cubed. So I think we just need to divide, right? We have how many gallons we have. We're going to divide it by how many cubic feet per gallon, and they're going to give that to us as 429,851 gallons. So we went from volume in feet cubed, we turned it into gallons by using the conversion rate that they gave us. This is now in gallons. Now, the question asks for what is the weight. So we go back to the directions and we see that a gallon is 8.33 pounds. So I take how many gallons I have and I'm going to multiply it by 8.33 because that's how many pounds per each gallon. And in the end, I'm going to get a total of 3,580,000. I don't know if you can, yep, you still can. 580,659 pounds. Wow, that's a lot. Well, so I found the volume of the rectangular prism. I converted it into gallons using their conversion rate. I multiplied my gallons by how many pounds per gallon to turn it into a weight, or how many pounds that whole aquarium takes. Okay? All right, example number 3. What they're trying to teach you here in example number 3 is something called Cavaliere's principle. And what that means is if I have a cylinder like this, pretend it's like a stack of CDs, and then I kind of push it and it gets slanted, would it change the volume at all? The dimensions might change, right? Like something, it's gonna have a slanty side now instead of straight up and down, but will the volume or how much stuff in it actually change, or is it just a different shape? It's just slightly a different shape, so the volume doesn't change at all. So this principle says if you have the same dimensions, it's just one's kind of slanted and instead of straight up and down, you're gonna have the same volume. You can solve it the same way. Okay, so volume of cylinders on page 751, it's the area of the base times the height. It's the same exact formula. In our case, the base is a circle, so you have to do pi times radius squared times the height. Let's look at example 3. Find the volume of the cylinder. Give your answers both in terms of pi, that means don't actually put pi in your calculator, just leave it in your answer, and rounded to the nearest tenth. I'm just gonna let you do one or the other. You don't have to put both down, okay? Just give me the answer, whichever way you prefer is fine. So we would do pi times 8 squared to do pi times radius squared, and that would be 64 pi. And then we would multiply it by the height, which is 12, and we would get the volume of that cylinder, okay? Sometimes we have to work backwards, like example 3b. On example 3b, we have to work backwards. We have to do it quickly because my time is kind of getting finished up here. I'll leave that. So we're gonna look at the cylinder with the base area, which remember, area of a circle is pi times radius squared. I know it equals 36 pi. So let's solve for radius. Divide by pi, goes away. Square root, and r would be 6, right? Probably not minus 6, probably just plus 6. So our radius is 6. Then it says the height is equal to twice the radius. So the height is equal to twice the radius, so the height would be 12. Then it says to find the volume. Okay, no problem. Area of the base times height. So we can go back to our area of the base, pi times radius squared. When we have that, we're gonna multiply it by 12 because that was the height we found, and we will be done. Okay, pi times 6 squared times 12, and we're done. So you just have to work backwards sometimes to get the missing piece that you need, okay? Lastly, real quick before you go, last chapter we learned about how if I change 2 dimensions on something, like if I double the length and the width, the change in the area is 4 times as much, right? So the rule for volume is you would just cube the change. Okay, so remember last time when we were dealing with area, if I changed the length and the width by 1/3, the change in the area was 1/9. Remember that? Because you squared the change. Well, when we're doing volume, you cube the change. So on example number 4, if the radius and the height, remember 2 things have changed. If the radius and the height are changed by 1/2, so that's my change. To get the change in the volume, you cube your change. So we would cube this, which would be 1 over 2 times 2 is 4 times 2 is 8. So the change in the volume would be 1/8. So you cube it instead of square. Area, you square the change. Volume, you cube the change. Okay? Lastly, example number 5, to find the volume of composite figures, just find the volume of the different pieces and add it all together. Go.